Yeah, good morning all. In today's lecture, let us discuss about alternating current. So the alternating current are that current which passes through a cycle of changes at regular intervals of time. Now let us draw the waveform of this alternating current. It will be in such a way: 0, t by 2, t on x-axis time, and on y-axis voltage or current. Right? So now 0 to t by 2 we call it as positive half cycle. T by 2 to t we call it as negative half cycle. 0 to t we call it as complete cycle. And the time taken for this complete cycle we call time period, denoted by capital T. Right? Now next, at the same time, the number of cycles per second we call it as frequency, and written as F equal to 1 by T. Okay. So now this value we call it as peak value. So this indicates the peak voltage or current. Right? Now here these either alternating current or voltage are written in terms of sign terms, such as I equal to I naught sin omega t, E equal to E naught sin omega t, where omega t indicates the phase. Okay. Now let us go for some formulas related to this alternating current or some mathematical formulas. Right? First one, the value of average value of AC during complete cycle, either it may be current or voltage, will be equal to 0. Similarly, the average value of AC during half cycle, if voltage E average equal to 2 E naught by pi, if current 2 I naught by pi we will get. Okay, if current we will get 2 I naught by pi. Similarly, RMS current value I naught by root 2, RMS voltage value E naught by root 2. Next, form factor, which can be defined in terms of current or voltage as RMS value to the average value. So in terms of current we will write IRMS by I average, and in terms of voltage we can write it as ERMS by E average. So IRMS value is I naught by root 2 and I average is 2 I naught by pi. Right? So we will get 1.1 as form factor. Then for what we use form factor? For what means it gives the identification of wave shape. It gives the identification of wave shape of alternating current or voltage. Now next, let us go for the relationship between the current and voltage when AC flows through pure resistor. So here resistor is connected to this AC generator. Let the EMF of this AC is E naught sin omega t. Let it put as equation 1. Now, according to Ohm's law, when the current flows through the resistor, there will be a voltage drop and that will be equal to IR. So, comparing the both equations, we will get IR equal to E naught sin omega t, but I equal to, I am sending R to this side, E naught by R sin omega t, or I is E naught by R is nothing but current. Maximum current we will call. So I naught equal to E naught by R. The maximum current we will call. So sin omega t. Let's put it as equation 3. Now see equation 1 and equation 3. Equation 1 E equal to E naught sin omega t, and equation 3 I equal to I naught sin omega t. So from these both equations we are clearly understanding that current and voltage are in phase. They flow in same direction. Okay, they flow in same direction. They are in phase. Right? Now let us draw vector diagram. or we also call it as phasor diagram. First let us know what is vector diagram. Nothing. The simple thing is, by taking voltage and current as vectors and phase as angle between them, if we draw a diagram, we call it as phasor diagram or vector diagram. Right? Now how we will draw means, either we can, in two ways we can draw this vector diagram. Now see, O, A. If this is the voltage, then current and voltage are in phase, no? So current will be also in same direction, OB. So OB is the current and OA is the voltage. Right? Or we can also draw it as in such a way. Right? So 0, pi, 2 pi, voltage or current. Right? So now if this is the voltage, E naught sin omega t, both are in phase, no? So this becomes current I naught sin omega t. So this is the relation between the voltage and current when AC flows through pure resistor. Right? Now secondly, let us go for when AC flows through pure inductor. What happens? Let us see. Now let us join the inductor to this AC generator. Right? Let the EMF, it will be EMF of AC, E naught sin omega t, equation 1. Now as we know, when current flows through the inductor, a back EMF is formed. So that back EMF is equivalent to L di by dt, equation 2. Now comparing both, we will write L di by dt is equal to E naught sin omega t, or di equal to E naught by L sin omega t into dt. Right? Now let us integrate it. When we integrate, integral di equal to integral E naught by L sin omega t dt. Right? Now integration of di I, that is equal to E naught by L minus cos omega t by omega we will get, and this minus cos omega t can be written as sin omega t minus pi by 2. Okay? So E naught is the maximum voltage. Omega L we call it as inductive reactance. Inductive reactance. So E naught by omega L, we can write it as maximum current I naught, no? Voltage by reactance. Reactance means nothing but opposition itself only. So we can write it as I naught. So now I equal to I naught sin omega t minus pi by 2. Now what is our equation 1? E naught sin omega t. Now compare these two. What we are understanding? It is clearly here these two equations, from these two equations it is clearly understood that current lags behind the applied voltage. Current lags behind the applied voltage. Now let us draw the vector diagram. So if I take the voltage along x-axis, then we are saying that current is lagging behind this voltage with 90 degrees. Okay? or we can also draw in such a way, voltage or current, right? If this is voltage, the peak voltage, current lags behind, I am saying, okay, current lags behind the voltage, okay, 0, pi, 2 pi, right? Current lags behind the voltage by 90 degrees. Now let us see what happened when AC flows through pure capacitor. Now AC through pure capacitor. Now I am connecting the capacitor to AC generator, right? Now the EMF of AC, E naught sine omega t. Now if Q is the charge on plates of capacitor, then Q is equal to C into E. So Q equal to C. Actually, from where we got capacitance is equal to charge by potential difference. From that only we wrote it, from the definition of capacitance of capacitor, right? E value substitute E naught sine omega t. But we know that current means dq by dt, no? So that is equal to, so in place of dq, let us substitute C E naught sine omega t, right? Now the differentiation of sine theta, it is nothing but cos omega t into omega. Now it comes out in such a way. Now I will write this as E naught by 1 by omega c. Nothing changes will occur, right? Now again I will write cos theta as sine omega t plus 90 degrees, right? Okay. Now next, now here 1 by omega c is equal to xc. We call it as capacitive reactance, right? So maximum voltage by reactance, we call it as maximum current. So sine omega t plus pi by 2 I naught into. So now where I naught is nothing but E naught by xc. Now if we compare this equation, equation 3 with equation 1, we are clearly understanding that current leads the voltage by 90 degrees, So if we draw the phasor diagram, if this is the voltage, current is leading the voltage by 90 degrees, right? Or we can also draw in such a way, if this is the voltage, current is leading the voltage by 90 degrees. Current is leading the voltage by 90 degrees. I naught sine omega t, E naught sine omega t. So voltage or current along y-axis, now time along x-axis. So this is the relationship between current and voltage when pure AC, when AC flows through pure resistor, inductor and capacitor. Thank you.